In this question, there are two long straight parallel wires having linear charge densities lambda 1 and lambda 2. Distance between them is r. As part of the question, electric field at midpoint of the wires and force exerted per unit length by one wire on the other. First wire. Second wire. Distance between the wires are so both the wires are positively charged because the charge is not given. So midpoint electric field intensity to first wire will be towards right because positively charged wire. If you leave a positive test charge, it will be repelled and pushed towards right. E1. Same point, the second wire will push on the left side away from the wire, will be towards left, E2. Both are opposite directions. So the electric field intensity for a straight wire is lambda by 2 pi epsilon r, epsilon 0 if it's vacuum or air. In this particular case, the entire distance is r. So E1 will be at a distance r by 2. E2 also will be at a distance r by 2. This is a general formula. So before finding that, net electric field at the midpoint will be E1 along I cap plus E2 along minus I cap. We take common factors out, E1 minus E2 I cap out. So this minus is coming here. And when you find E1, will be at the half distance, R will be R by 2, lambda 1 by 2 pi epsilon R by 2. Same way, E2 also will be lambda 2 by 2 pi epsilon R by 2. So this is only the magnitude, the directions are opposite, this is subtraction. So we substitute the values of V1 and V2. Lambda 1 by 2 pi epsilon R by 2 minus lambda 2 by 2 pi epsilon R by 2. Common I cap. 2 get cancelled. Now pi ER comes out. Then lambda 1 minus lambda 2. So that's a total electric field intensity at the midpoint of the two wires. The second part, we want force per unit length by one wire, any one wire. So this is force on second wire. The force is due to the charge on the second wire. Charge on the second wire experience force due to the electric field of the first one. So wire 2, which is having charge Q2, is experiencing a force due to the electric field of wire 1. So F2 is equal to Q2 times E1. When you find Q2, you know lambda, linear charge density is charge by length. So Q2 will be lambda 2L2. So one part we already got Q2. E1. This E1 is the electric field intensity produced by the first wire at the location of the second wire. It's different from case 1, E1 and E2. Here E1 and E2 are electric field at the midpoint of the wire. Case 2, E1 is the electric field of wire 1 at the location of wire 2. The distance will be R total. So if we substitute both E1 and Q2 in F2 formula, will come as Q2 will be lambda 2 L2, then E1 will be lambda 1 by 2 pi epsilon r. This is the force on wire 2. If you want force per unit length, F2 by L2. So you can take this L2 to the left side. F2 by L2 will be lambda 1 lambda 2 by 2 pi epsilon r. That's the expression for force per unit length.